Hello and welcome back. That we have done the modeling assignment of elements, defined the elements, defined material and defined section for the steel structure of this warehouse. Now today we want to apply the diaphragms, loads, load patterns and load case to the warehouse of steel structure. So let me do the diaphragm definition. Make sure that your diaphragm is rigid. Okay, diaphragm purpose is to transfer the vertical loads of the slab to the respective beam and beam to the column. So uh, first of all I need to we have done the meshing of the slab. So in ETABS slab meshing is not too much important, only the because you need to consider this one if you are going to design the slab. But normally we are not using ETF for the design of slab. Separate sheets and SAF is for typically for the slab design and footing design. So let me go and define the load patterns. First of all, this is dead load. Dead load is self multiplier is 1. So this is the responsibility of the software that it will calculate, and this one means that I am giving this responsibility to the software. Like a beam, slab, column, these all load are calculated on the base of given dimension and density by the software. Now let me define the live load. Live load is 2, so let me delete one live load. Okay, so like here I add some this one, superimpose dead load, and click here. Already duplicated, no need to just other loads. Consider self multiplier is 0. I will add these loads like the same manner I have done for the live load and also for the superimposed load. This is wall load, live load. Okay, we are done with the loads. So let's again, and we have to check the load cases. Just select here, and we just go and select from the selection properties, frame, slab selection. Now I want to slab 1, select. So all slab 1 is selected, and go in the menu bar and assign the shell. From shell you go to diaphragm D1. Now you have assigned the diaphragm. Close this tab, and I want to apply the loads on different floors. So my load on the different floor is also different on the base of the storage, on the base of the usage of the floor. Some portion is my third third story is for official use, first and second story is for storage use, and ground floor is also for storage use. But my concern is about the first and second floor and third floor, not the ground floor. Ground floor is on the floor portion on the ground, so its calculation is not necessary. So here you can see in the drawing, this is a first floor, and this is ground floor. Ground floor is storage, cement, and first floor tiles, and second floor is PVC. So this is my load calculations for the base on this storage. Tile storage we consider 18.5 kilonewton per square meter based on unit weight of the tile. So unit weight of tile 24 kilonewton per cubic meter. So multiplication of here is we have put This is our panel size, and on this panel size, these are the beam on the periphery, and this is our storage stock size. This is stock size. So stock size multiplied by the height of the stock, area of the stock multiplied by height of the stock, we come out, we come out and multiply the unit weight. So we come out the total weight in kilonewton divided by total area of the slab. So we come out for the dead load of tile 18.5, and likewise for the dead load of PVC we 10.4. Now we consider the offices live load. Washroom 2 kilonewton per square meter, corridor 3 kilonewton per square meter, storage 6 kilonewton per square meter. So let me apply the where is the storage. Storage is first story. Storage is first story and second story. Let me go and use the similar storage similar modification here, and modify show story, and from here this is considered none. First none. Apply. Okay. Okay. So let me make the selection from the in the 2D. Click here and rotate, and make your selection like this. So you have selected only the roof. So assign frame load, uniform frame load, and you need to consider the SDL for the superimposed dead load for the roof. So from here, superimposed dead load for the roof is 2.5 kilonewton per meter square. Click here, 2.5 kilonewton per meter square. So just click and apply. Apply. If there is any existing load, apply. Previous selection, apply. Okay. So live load on the roof. Let me check the live load on the roof is 1 point. It depends on the snowbound area. It depends on the arid area. So 1 point, in my case 1.5 meter kilonewton per meter square. 1.5. If you have load there, so you can apply. Okay. Previous selection. Okay. Now you can change your model. So this is our load application on the roof. Okay. So let me check and make this one as an elevation view. And now I am at story 2. If my selection for the story 2, it will select automatically. Okay. First and second. So for first and second, dead load is live load is 6 kilonewton. So I can apply the 6 kilonewton. Assign uniform 6, but you need to change. This one is live. Add replacing. Okay. If you have here, so replace then this one. This is no need to. Okay. Live load for the, this is my official area, corridor area. So I will consider 3. Here already I already apply. This is live. This is 3. Replace existing. So this is we have done with this. Now we have come up on the third story offices area. So come up with the offices area. So offices area we need to select and assign live load, office area live load is 4.79. These loads you can get from the codes, and you can get from your experience, and you can get from your calculations. So 4.7, 4.79, apply. And one thing here, that there is three options, add to existing one. If you apply this one, so it will become previous selection, it will become double, okay, 9.58. But I want to replace existing load, okay, previous selection, okay. Now we have done the offices, so I will apply the dead load on the same offices. Superimpose dead load. Other dead load is considered by the software and responsibility of the software. So let me go. Offices 2 kilonewton per meter square dead load, 2 kilonewton per meter square. Now let me little bit down and apply the dead load of the. Now I am story 2. So now I already on the similar story case. So let me select this portion, and this is actually the official area. So official area dead load is 1.2 dead load for official area 2 kilonewton per square meter. So go and apply SDL, apply. And now we are going to apply, change this one into one story, because my story 3 story, now I add story 2. Story 2 storage is PVC tiles. So PVC tile, how we calculate, it's already I have told you that unit weight multiply by the height. So now I am just PVC tile 10.4. I apply a superimposed dead load is 10.4. Replace existing one and just go down and select this one, and just consider 18.5. Replace existing one, apply, okay, and go and check, select slab loads, live load 4 point, wall load. So okay, in this case, now we have the walls only on the peripheries. On the peripheries we have walls. So these walls are on all arms, all stories. So this is periphery walls. We consider these partition walls as a dead load. So I will apply this on the all stories. Like I make the similar story of third also. I will make similar story. Okay. Now let me select this portion, only this portion. But there is one story on make on similar story, clear selection, again select, and this is similar story I already. So this area is our are the official, and some partition walls and block masonry walls there. Some is some is block masonry walls. So we will make this one as a calculation of these wall divided by this area. So already I calculated in the Excel sheet. So this is the additional dead load 4 point. 5 kilonewton square meter in this area. Assign, assign frame load, assign 4.5. नॉट, इसको हमने क्या करना है, इसको एडिशनल है तो इसको ऐड टू एग्जिस्टिंग वन करना है। ओके, इसको एग्जिस्टिंग वन पे ऐड करना है, जो भी है उसके साथ ऐड करना है। ओके, ये एग्जिस्टिंग वन के साथ अपने हिसाब से ऐड हो गया। इट वाज एडेड बाय on the base of the previous load, no 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 no. Let me go one step back. Why this 18 point? Okay, okay, this was 18.5 is the SDL. Okay, this is the storage of the tiles, tile load. So now let me do uncheck all these applications, fill object, joint, floors, apply. Okay, and make the similar stories, and we have all stories are now similar, first, second and third. Select, 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 select. So we have all three stories are selected. So let us apply the assign the frame load, distributed frame load, replace existing one, but this is wall load. Make sure that load pattern should be changed. It's first priority. For this wall load is unit weight multiplied by thickness of the wall, 0.2 meter multiply height of the wall, so we will come out 14.4 meter. So it's 14.4 meter we have applied here, and apply. So this is okay. So now our model is, let us check the model in 3D, and here are the load applications, display, loads, wall loads. So wall load already we have applied. So we have ready our model to run, but if before run we need to check our model. Check our model. Okay. So no warning. If later warning is okay, so we can go for first define load patterns, load case. Already know we need to combine the load combination. Is default steel frame. Okay. Shift and delete these previous combinations. So almost our model is ready for the run, to run, and let me run the model. Okay. So this is our dead load on base of the displacement on the base of dead load. So I will now off my one window, and display deform shape, layers of load combination, maybe 2 or 3, apply. So this is we have done the some animation. If you need, just go and check stories, apply, and this is our frame design, so you can choose your preferences. Euro code, this 2005. Okay, so this is automatic code and design. Start design and check. From this tab, design tab, you can design your model. So steel frame structure model is already designed, and these are the braces. uh, I section is given, so we can show on these sections. So here is HE, this is 40, this is I section. So likewise we have column beams already from this section. This is auto list. From the auto list it was decided, and on the base of demand the software calculated, and we are come out with the most economical and most less area section to bear all these loads. So all the floors we have calculated, and this is our model is in this case is completed. So let me show you some shear force and bending moment. So shear force and bending moment. So this is our braces we have applied. So let me show you display. Okay, so moment 3 3, we have this moment here, so we can check. And okay, so this is moment 3 3, share 2 2. So we can get the share 2 2 here from this section. Like we can get the elevation, any elevation is okay. Display, show force, pair support, FZ. So we have come out with the reaction force. On the base of this reaction force we can calculate and we can design our footings. So this is all about the